Hello everyone, welcome to the third video in the series Medium Access Methods. Today we're going to talk about another technology called Enhanced Distributed Channel Access, or EDCA. EDCA essentially is the means by which quality of services is enabled in the wireless LAN world. Now, what is EDCA and how does it differ from the first technology that we discussed in the first video, which was Distributed Coordination Function, or DCF? EDCA introduces an enhancement which is an ability for the frames to be assigned an access category. Right, so the frames can be grouped into 4 access categories. This can be background, best effort, video, and voice. So as you might have guessed, these 4 access categories are used to segregate priority traffic. Apart from that, there are a couple of variables which are introduced by EDCA. So when I say variables, these are values which can differ based on what is the type of frame which are going to be transmitted. One of the first variable that we are going to talk about, or the first concept which varies with EDCA, is the values for CW min and max. Now again, if you have seen the first video, CW min is value of the contention window, or the range of values within which a value is chosen to be a random back-off countdown timer. Now what EDCA does is that it ties different minimum and maximum values for the contention window depending on what is the type of frame, or rather what category is the frame assigned to. The categories are the ones that we spoke earlier: background, best effort, video, and voice. The second variable that EDCA brings to the table is a different form of interframe space. Now this was again discussed in the second video in the series, that EDCA uses a different type of interframe space called AIFS. Now the variable that is introduced is the type, or is the length of the AIFS field. So every frame, depending on the access category, is assigned a different AIFS number, right, which is associated, and the number is in turn associated with the access category. So naturally, higher priority access categories have lower AIFS numbers, and lower priority access categories have higher AIFS numbers, that these high priority traffic can get access to the medium probably more frequently than the lower priority traffic. Now for instance, the CW min and max values for voice as an access category would be 3/7, which means 3 is the CW min and 7 is the CW max. For video, it could be, or it is 7 and 15, and for background and best effort, both the CW min starts from 15 and can go up to 1023. And the AIFS numbers for these access categories: 2 for voice, 2 for video, 3 for best effort, and 7 for background. So each one of these mechanisms help the higher priority access categories, which is voice and video, to get access and stay on the medium more frequently than a normal data traffic, than a normal best effort traffic. One important point to consider here is that quality of service has to be always end to end, which means that the mechanisms that we discussed earlier in this video are pertaining primarily to the wireless LAN side of things. It is generally the responsibility of the access point or the controller to translate the wireless QoS into a wired compatible value, depending on what configuration is present on these devices. Now this also means that the access categories, or the way of prioritizing things at the wireless LAN level, should also be carried forward through the wired segment. So this is how the priorities are are derived in the wired segment based on the access categories as shown in the table. So the column 2, which stands for 80.1D priority, is listed with the CoS value, the class of service values, which are mapped to the different access categories, and in the second column, which is the DSCP values, are the DSCP values which can be assigned respectively to each of the access categories. Now let's talk about Wi-Fi multimedia, or WMM. Now, what exactly does WMM stand for, or what is its objective? WMM is a Wi-Fi application that indicates whether a device supports EDCA as defined in the standard or a subset of EDCA. So using WMM configuration on most of the vendor access points or controllers, one can tune the EDCA parameters, although this might not be always necessary. The stations which are connecting to the BSS look for the WMM parameters which are supported by the BSS or the AP or the controller. Now, how do they come to know? Now, in every beacon frame and a probe response, and also an association response, we will see WMM specific information being exchanged between the AP and the station. So the AP will announce in every beacon frame what are the different WMM parameters that it supports or it wants the station to use. The station, on hearing this response in the beacon frames, has to update its own WMM parameters to match that of the BSS. So this in turn results in shared parameters throughout the BSS between the AP and its stations. What are the different parameters that one can see in the WMM information elements that are present in the beacons? Well, you can see the value of CW min that the AP wants the stations to use, the value of CW max respective to every access category, the value of AFSN, and also the TX op that stations can use for these different access categories. Now, the TX op is essentially the maximum, or it stands for transmit opportunity, and it defines the maximum amount of time a station can use to transmit a burst of frames. Now, for instance, if at all it is a frame belonging to the background access category, the TX op is 0, which means that it can only transmit one frame once the station gets access to the medium. Lastly, let us look at a real-time packet capture, or a snapshot of the packet capture. In this case, a beacon frame, and look at what are the, or how do these parameters. So, like we see in this slide, this is a small snapshot of the WMM information element as seen in a beacon frame. And as you can see most of the information that we discussed earlier in this part of the capture, right? So there are 4 access categories which the access point is broadcasting in its beacon frames: the best effort, background, video, and voice. You have AIFSN numbers. If you remember, we had looked at this in the table a while back, that it is defining, okay, that if this is the access category, this is the interframe space value that you have to choose. The ECW or the CW min or max for each of these access categories, and the transmit opportunity that you get if you belong to any one of these access categories. Now, as you can see, the transmit opportunity higher in the video and voice side of things, and very low in the background and best effort types of packets. With that, we conclude the video series on medium access methods. I hope this video series was informative, and I will be posting, or I'll be starting a new video series on MAC layer